I told you on Wednesday that we have one more section to talk about, which is 4.8. Not super difficult, but we will be reviewing story problems, which is in there. What? I did do my nails. Thanks. So we are talking about something called harmonic motion, which sounds like it's tricky, but it's really not too bad. And then we're going to review story problems. Okay, my intention is to only do a little bit of review on the story problems because we did that way back at the beginning. Okay, so harmonic motion basically means that, well, let me back up. So when we talk about harmonic motion, what we're going to be doing is writing an equation. So it's the reverse of here's something, you graph it. It's going to be, I give you some words and you write an equation for it. Okay. So there are things in real life that can be modeled by that wave shape pattern. Okay. The sine and cosine pattern. So anything that's cyclical. So we'll talk today about tide, like tides. I know that we do not live by the ocean, but the ocean has tide. Cyclical. Has a cycle. Okay. Right? That it goes in a cycle. So like tides go in a cycle. It's like a 12-hour cycle, I think. I don't know, because I also don't live by the ocean. Anything that's waves, like if you were able to chart waves at the beach, a spring. So we'll do an example of a spring. So there's lots of different things where you can talk about writing the equation in terms of sine and cosine. So anything with harmonic motion has a cycle, okay, which is cyclical cycle. There you go. Okay. So I want you to think about a spring. So this is not going to be a good drawing. If you had a spring, there's your spring, with a heavy weight on the end of it, and it's just sitting there, what happens when you pull the spring down? It goes down, right? Sorry, that was a goofy statement. There's your spring. And then what happens when you let go of it? It goes back up, right? But it goes up past this, right? Because it shrinks way up, and then it goes down again, and it goes back up. So it's going to be little, it's going to be up here, right? So you have this cycle. And if there was no friction and no air resistance and all that, it would keep going forever. Okay? We're going to pretend we're in that perfect world. So if this is what we will call equilibrium, this guy goes 10 below, and he goes 10 above, not drawn to scale. And ends up back at that midpoint after 4 seconds. That's a very slow spring. If we have this information, we can write something that is in sine and cosine. Okay, we can write an equation that's in sine or cosine, and it really will only have 2 pieces, 2 numbers in it. It will have a number for amplitude, and it will have the number that changes. It will have B, which is the one that deals with the period. Maybe that's it. Okay, so if you get out your purple paper, page 5. A couple things I want to remind you that sine starts at the middle, and cosine starts where? At the top, right? So if we're dealing with this situation where we have a spring at rest, and then it goes down and up and then back to its equilibrium, are we looking at something related to sine or something related to cosine? Looking at something related to sine because it starts in the middle. Okay, so we're going to write an equation. This equation is going to be sine. What's the amplitude? 10, because it goes 10 below, 10 whatever's they are, whatever units I chose, which I didn't specify. It goes 10 below, it goes 10 above, so I know that this is 10. Now, the only thing that's a little bit different that we have not done before is that we are going to use this to find b. We know that we do b equals 2 pi, the period equals 2 pi divided by b when we graph. This time, I actually know what the period is, and that lets me figure out what b is. So my period is 4. So if the period is equal to 4, then this tells me that the b is 2 pi divided by the period. So b is going to be 2 pi divided by 4, which is what? Pi over 2. Pi over 2, just reduce those, right? So it's going to be pi over 2 and then x or theta, whichever way you want to go. I'm going to go x. Okay, we're almost done. The only problem that we have, if I graphed this guy, it would be 4 and it would be 2. It would look like this, right? And would go up to 10. It would go down to negative 10. What's the problem? So what do we need? Yeah, because it's reflected. It goes down first and then it goes up. So it just throw your negative in the front. The ones that we deal with will not involve any phase shifts, so rights or lefts, and it will not involve any shifts up or down. So why this is called simple harmonic motion. So the only things that you potentially will have is the number for the amplitude and the number for the period. Okay, super easy to figure out. Because amplitude, you got to have the information about how high and low it goes. And then this guy is what you need to do to get B. You do 2 pi divided by the period, which is on your paper, 2 pi divided by the period. Okay, so let's try, let's do this one. Let's talk about tides, which I know that we don't have a lot of experience with. But you guys, you go from high tide to low tide. Did you just say you're in a roll tide? Nice. So let's say for this one, the tide varies 3 feet above and below normal. And it takes, you think about this, it takes 12 hours to do a full cycle of tides. And then we're going to start at high tide. Okay, so sometimes it helps my brain to draw a picture. Just I've started at high tide and I go down to low tide and I go back up to high tide. If you do that, it helps your brain figure out which equation to use. Which one you're going to use? Cosine, because we're starting at high tide, which means you're starting at your maximum. So you know it's cosine. What's the amplitude? 3, because you're going 3 feet above and below the normal cycle. And then we do 2 pi divided by 12 to get whatever b is. What's 2 pi divided by 12? Yeah, pi over 6. So pi over 6 times x. Is it reflected? Nope, you're done. Yeah, don't forget to name your function. Okay, let's do this one. Okay, let's say you've got Ferris wheel. I'm not drawing the whole Ferris wheel because that takes too much time. we'll say it's a Ferris wheel, but it's kind of in, it's encased. And so you go up. Here's where you would get on. Okay, here's your entry. Yeah, and so you're going to go up, and then you're going to go down below the floor, and you're going to go up. Okay. So this is your normal spot. This radius, okay, the radius of the wheel is 20 feet. So 20 feet. And it makes one cycle in 30 seconds. And it's going this direction. Okay, so we're writing an equation that models, like if you were in this seat here, that models your height from your entry point. Yeah, you get in the middle. So it was below ground. It's very exciting. Yep. I feel like it's like a haunted house, right? And so you go up and there's ghosts and bats, and then you go down and there's creepy mummies. Okay. So writing an equation for that seat.
You're basically thinking of like your height change on your graph.
Mm-hmm.
So like as your height goes up,
You're looking at your height. So we're really writing an equation for height above center.
it's got a diameter of 40 feet.
Thank you. Thank you for that, Connor.
I'm just using what I know.
Okay, so talk to me. You're going to get on here, which right there, I shouldn't even have to draw anything else or using sine or cosine. Using sine, because you're getting on in the middle. Okay, you are going up, and then you'll come back down, and you'll hit center again, and then you're going to go down. So it's regular old sine. Yes, sir.
If we don't need to draw like a picture,
Don't draw it.
we don't have to.
No.
We won't get points on
No.
the actual word.
Nope. I'm just giving you strategies in case it's not going to work for you.
Oh, so the amplitude.
Yeah. Right? Because the highest you get above your center is 20.
That's mad easy.
So 20, we know it's sine
15.
pi over 15 x.
That's so easy.
So-
The picture confused me more than it helped me.
Okay, don't use the picture then. Let me ask you this question. If you were going the other direction, so not going this way, but going the other way, how would that change your equation? It would be negative in the front because you're going down first instead of going up. Okay?
Wouldn't this technically make the B negative because you're going backwards on the circle? From the way it sounds.
No, because you're still graphing your height, right? So your height, you don't like my picture, but I'm going to go with the picture. Starting in the middle again. You're just going down instead of going up.
I'm saying for like the original, because you're going like backwards from the entry point.
You are overthinking. Okay, what are your questions on this? Really what you have to do is figure out amplitude and figure out how long does it take so you can figure out B and pop them in their equation. Nope, not yet. Okay. So let's talk story problems. Quick second. Oh my goodness. Okay, so I'm pretty sure I did this before, but we're just gonna review it because I know it's been a while. So let's say you are in a hot air balloon. Quite high. We're gonna go. You are 3,000 feet above the ocean. Okay, so here's my hot air balloon. Okay, here's the ocean down here, 3,000 feet above the ocean, and you're looking down at an island. Okay, so you're above the ocean. You're looking down at the island. Your angle of depression. This is feet. Angle of depression to the front of the island is 24 degrees, and the angle of depression to the back of the island is, we're gonna go 20 degrees. We want to know, how long is the island? Okay, so there you go. Yeah. So what you have to remember, the things that you have to remember is angle of elevation is from horizontal and up. Angle of depression is from horizontal and down. Okay, angle of depression and angle of elevation are always made with horizontals.
Is the
Inhabited?
Yes.
Yes.
Inhabited by
Coconuts.
like
It is.
Do I get a pet chicken? Dude, I want to be more.
You want to be more?
Hey.
Okay.
Chicken and a pig, and that's all I need. I'll make no way.
So listen.
Anything but good. I want to be the big
You guys, if you do this, okay, 2 triangles.
That's a really good line.
Yeah. Again, to answer your question that you haven't asked but is on your mind, you don't have to draw the picture, but this one, angle of this is 3,000 feet because you're above the water. Angle of depression to the front of the island is 24 degrees. Angle of depression to the back of the island, still 3,000 feet, 20 degrees. Okay. Do you need diagonal or horizontal to figure this out?
One of them.
You need horizontal because you're trying to figure out a horizontal distance here, right? You're trying to figure out this. So you got to have the horizontal distance. Yep. How long is island?
I didn't know what we were trying to find.
Does say, how long is island?
I didn't know either. Then I read it and I told you.
I'm laid off and dyslexic.
You do?
So question, sine, cosine, or tangent?
Oh, wait, I got this.
tangent.
But don't.
I was getting there.
Somebody else answered the question. So it's opposite over adjacent. What do you do with these guys here?
You just plug it in the X for tangent.
No, you swap them.
That's it.
Okay.
That's what I said.
Uh-huh.
Plug it in the X for tangent.
Okay. So you get, this one is 6738.1. Why are we still doing this? Opposite over adjacent, swap those two, and you get y equals 3,000 tangent 20. So this is 80 to 42.4. If I want to know how long the island is, what do I do with those? Subtract them. Yep. No, you subtract the small one from the big one. Yep.
1504.
Yep, 1504.3. That would be feet. It's quite a small little island there.
Do I really need the decimal?
Yeah, you do. So you can see this one's similar to the one that we did on our warm up. So here's another. We're gonna do 2 more examples. So let's say you have a blimp. Do you guys know what a blimp is?
Yeah.
Okay, so blimp's flying up here. Yeah.
For sure.
Okay. Yep, the Goodyear blimp. So the blimp is flying above a road. And we're going to say it's...
Yes, I promise you there was.
If some guy can own a stupid.
This guy's driving.
What's the other thing we got? Like the whole
Lindenberg is called a dirigible, but similar. A Zeppelin.
Can you scoot your paper down?
Yeah.
It looks like a hat. I think Michael has one of those for example.
The first thing that drives it goes right there.
What am I going to install?
I know there.
I'll even install solar.
Stop correcting my
That'd be really big.
Okay. So, in this situation, we have a blimp flying above a road. And it's above the road and between 2 parked cars. Well, a car and a truck. They're very nice. So the angle of depression to the car is 35 degrees, and angle of depression to the truck is 23 degrees. I want to know, how far apart are they?
Uh-oh, Trevor, this is what you're bad at.
How far are they from each other?
Yep. How far are the 2 vehicles from each other?
I believe in you, Trevor. You got this. That's not a lot of faith in yourself, but I applaud it.
Angle of depression, horizontal and down.
Damn.
Down. Listen,
Yeah, I'm failing.
logical. Depression is down. Depression is down.
And you want what happens when you're depressed? You go down.
Let's go down.
Horizontal or down? Okay.
I think I might.
It's like,
No.
what's the regular depression from the,
Let's go down.
yeah.
I'm the. You know that song?
Yeah. I'll be the one.
So you want to make sure
Signature bottom.
that you are going horizontal and down.
No. You don't even know.
Go on.
Ooh, yeah.
Oh, I think this is supposed to be a opposite.
Joanne, you want to do the talent show? Duh.
I changed my mind.
Nope.
How? Sure.
And then you can sing together.
So I definitely rolled these wrong spot. One second.
Okay, so you guys, the thing that's gonna make or break you, Grayson, is if you put your angles in the wrong spot. Okay, horizontal and down, horizontal and down, not at the bottom. Depression is not at the bottom. Depression is horizontal and down. So you're looking at this. You want to find this guy. You want to find this guy. So it's tangent again. So tangent of 35 equals opposite over the adjacent.
I think I did this wrong.
And tangent of 23 equals opposite over adjacent. So we're dividing, not multiplying here. So 2,500 divided by tangent of 35. This one's 3570.4.
Yeah, I definitely got this wrong.
How did I do this wrong? I'm literally dividing.
What are you dividing?
Javon,
500 by tangent of 23.
are you in degree mode?
Ah, very good.
I am in degree mode.
I'll come look. So they are 9,460 feet apart.
See, I did that the other way where you multiplied it.
Yeah,
And it gave me a reasonable answer too, so.
You didn't divide this one.
Oh, you're right. That's mine.
Okay, last one.
I didn't get it right.
We talked about this back when we first did these. We're talking about it again. So let's say you are trying to measure a tree, big tree. You're out in California, looking at redwoods. Okay, they're very big. And you start out here. Your angle of elevation to the tree at this point is 35.4, and then walks 20 feet this way. And the angle of elevation here
This is where I suck at.
is 42 degrees. How tall is the tree? Yep, 20 feet toward the tree. Okay, so I want you to listen to me, okay? The thing that's the most important to know, this is a harder problem. The way that you know it's a harder problem is you appear to be missing information, right? There doesn't seem to be enough information for you to figure out how tall the tree is, okay? If that's, right, I don't have enough. I don't even have a full triangle here, okay? Oh, good. I'm glad you know that.
I can estimate, yeah.
Okay?
It's about 65.
So when you have this situation, this is where you have to magic up some variables. Okay? So we're going to go, how tall is the tree? We're going to call that H for height. That's what I want to know. And this whole side, which I also need to know, I'm going to call this X. Well, hold on. So I've got two triangles here. Okay, there's the first triangle. And I know his angle of elevation is 42 degrees. So what can I write that's true statement?
We know the angle on the other side.
Well, hold on. Yes. So tangent of 42 is equal to H over X. Okay, now my other triangle is here. Let's go with green. Here's my other triangle. Okay, I know his angle of elevation is 35.4. So tangent of 35.4 is equal to the opposite over what's the adjacent? There's your x plus 20. Now, they both have the same variables. They both have x's and h's. So this turns into a system of equations. It's easiest to solve for h in this because I can make h multiplied by x here. H is equal to x times tangent of 42. And over here, h is equal to x plus 20 times the tangent of 35.4. Now I set them equal to each other. Okay, because if they're both h, then they have to be equal. So I'm going to turn tangent 42 into a decimal because I don't want to deal with anything else. This is a 0.900 actually. X equals tangent of 35.4 is 0.711 times x plus 20. Now I've gotten rid of all the tangents, and this is a linear equation. What do you do to solve this?
You have to distribute the points.
Yep. Yep, you do. I suppose you could divide by 0.711. That'll get you some ugly numbers, but doesn't matter. So, okay. So this 0.9x equals 0.711x. This is 14.22. Okay, what are you going to do, folks? This guy has to move to the other side. You got to subtract. So you have 0.189x is equal to 14.22. So divide.
We doing all this work just to find the height of a tree, bro.
Okay, now this is x. Make sure that you're getting the real thing, which is how tall is the tree. So I would put it back in this one. That's the easiest one. So multiply that times tangent of 42. So 67.74 feet. Okay, so insanely close. You're correct. So you do have homework tonight. That's page 335.
Well, you shut up. He's the most talkative in this class, bro. I want to hear it. Oh my god.
29, 30.
I think we should take away
31, 32.
Yeah, shut up.
Okay, I want you to look at, open your book to 338. I want you to just look at what you're going to be doing so that you're not like, what the heck is this? 57 to 60, 66, 76. Okay. So when you get to 57 and 58, 59 and 60, this first time I was like, this is weird. They're telling you it's harmonic motion, so it's going to be sine or cosine. This is telling you where it starts. So at 0, it's at 0. So if you're starting at 0, is it sine or cosine? It's sine. Okay. This one tells you you're starting at 3 inches and the amplitude is 3 inches. So does that mean you're using sine or cosine? Because you're starting at the top. Okay, so that's what this means. It's where you start. So don't freak out when you see that. They're just telling you where it starts. That's what you got to know. So here's your assignment. If you are gold star, give me a second and I will I want you to do 30 and 31. 58, 59, 60, 66 you got to do, and I think 76 you got to do. 66 is going to be similar to what's on the quiz. As far as, yeah, we'll just go with that.
Can we kick your out?
No.
You really weren't.
So tomorrow's plan is that we will go over the homework. So if you have questions, you're going to get them answered, and then we will take our quiz.